Dividing polynomials by monomials. One of the easiest ways to understand what to do here is to use a real-life example. So let's start out with an example dealing with something we all like, money. First, Jimmy has 6 loonies, 12 quarters, and 15 dimes. He is in an extremely generous mood and wants to give these to his 3 friends. He wants to divide them among his 3 friends. So let's start by writing out a mathematical expression for the coins. Well, before we can do this, we need to let a variable represent each type of coin. Since loonies start with an L, we are going to let L represent the loonies. We're going to let Q represent the quarters and D represent dimes. Part 1. Write an expression for the coins. Well, what do I know? He has 6 loonies, so that would be 6L. He has 12 quarters. That would be 12Q. Now notice, these coins mean different things, therefore they are not like terms, which is why we gave them different variables. And he's got 15 dimes. Next, divide each of these by 3 because he wants to give each the same amount to each of his 3 friends. Well, we would divide each of these by 3 or the entire thing by 3. Now, in your mind, you should already be going, well, if he's got 6 loonies and divides them among his 3 friends, that's going to be 2 loonies. Or what you're really doing is you are taking each one of these and you're dividing them by 3. And that's a key for polynomials. We take each term in the numerator and divide it by the monomial, the denominator. So, how many coins does each friend get? Well, 6 loonies divided by 3 is 2 loonies. 12 quarters divided by 3 is 4 quarters. And 15 dimes divided by 3 is 5 dimes. So how many of each coin do his friends get? Each friend would get 2 loonies, 4 quarters, and 5 dimes. Now, we can divide polynomials using algetiles and algebra. Why don't we start with algetiles? Divide 4x squared minus 2x divided by 2x. Now, first thing, my denominator is one of my factors. So what I need to do is draw out my 2 lines, and along one side of the lines, I need to place 2x. It could be on top, it could be on the side. I'm choosing to do it on the side. So what I'm going to do is put 2 x's alongside the line. Next, I need to take my numerator and divide it on the right-hand side across those 2 x's. So 4x squared means I can put 2 x's there, but remember, I need 4 x's. I cannot go any lower because I don't have any more x's, so I'm going to go across. I now have all of the required x squareds, but I do have negative 2x. Since my x's are going up and down on the side, I'm going to put my negative x in the same orientation. This should always form a rectangle, and it does. What I now need to do to find my answer is look at the shapes on the right and find out what side matches above the line. So, if with x squared, on one side I've got an x, what would I multiply x by to get x squared? That would be x. So on the other side, I'm going to put an x. But I've got 2 of them, so I'm going to put another x. Finally, I've got to ask myself, what goes above the negative x? So when I look at this, what would I have to multiply x by on the left to get negative x inside my cross-hatched area? And the answer is negative 1. So I now have all surfaces covered from the right-hand side, which means my answer is going to be 2x minus 1. Notice these are different shapes, which means they are not like terms. I cannot combine them. That makes that my final answer. Most people find using algebra a great deal easier. You're going to find that we've already done this when we did our money example. So what did we do with our money example? When we had a polynomial divided by a monomial, is we took each term in the polynomial and divided it by the monomial. 5x squared divided by 5x and 15x divided by 5x. I now divide these. 5 divided by 5 is 1. X squared divided by x is x. 15x divided by 5x is plus 3. These are not like terms, so that is my final answer. Stop this recording now and do 2, 3, and 4, and I will do them in a minute. Okay, I hope you've had a chance to try these. Number 2, what you'll notice is I've thrown in a negative value in the numerator, but we follow exactly the same procedure. We take each term in the numerator, 8x squared, and divide it by 4x. Negative 12x divided by 4x. 8x squared divided by 4x, 8 divided by 4 is 2, x squared divided by x is x. Minus 12x divided by 4x is 3. So my answer is 2x minus 3 because these are not like terms and they cannot be combined. Number 3. Notice I've now put a negative in the denominator, but I follow exactly the same procedure. I take each term, 9x squared, and I divide by negative 3x. Negative 15x divided by negative 3x. 9 divided by negative 3 is negative 3. X squared divided by x is x. So I have negative 3x. Now, negative 15x divided by negative 3x is going to be plus 5. These are not like terms, so that is my final answer. When you look at number 4, you may realize that this is a trinomial. However, you can still follow the exact same procedure no matter how many values or terms you have in the numerator. We take each term and we divide it up. 4x squared divided by 4, negative 12x divided by 4, plus 8 divided by 4. So now when we divide this, 4x squared divided by 4 is x squared. Negative 12x divided by 4 is negative 3x. And finally, 8 divided by 4 is 2. Again, none of these are like terms, so that is my final answer. Our final example is a word problem. This usually is a little bit more difficult for students. Number 1, what is the ratio of the surface area of a cylinder to the radius of a cylinder? Write the ratio in simplest form. Now, let's break this down. First, we want to know what the ratio is. Well, what is a ratio? A ratio is when we divide. It tells us how many times larger or smaller something is. So it says the ratio of the surface area to the radius. That means that surface area is going to go in the numerator. Now, how do we wind up taking this further and simplifying it? Well, we need our formulas. So hopefully you remember from grade 8, the formula for a surface area of a cylinder is 2 pi r squared representing the two circles plus 2 pi rh representing the curved part in between the circles. And we're going to divide that by r represented by, which represents the radius. All right, so notice we have a binomial divided by a monomial. So what are we going to do? We are going to break it up into 2 pi r squared divided by r and 2 pi rh divided by r. Now, we notice that we have r's in both the numerator and the denominator, which means we can cancel them out. We have 2 r's in the numerator and 1 r in the denominator. So r divided by r is 1, leaving us with 2 pi r in the numerator. Next, 2 pi rh divided by r. Notice we've got an r in the denominator and an r in the numerator. So we can divide those. R divided by r is 1, leaving us with 2 pi h, or 2 times pi times the height. Now, notice even though these look very similar, the variables are not the same, which means they are not like terms and we cannot combine them. So that would be my final answer. Or the surface area is 2 pi r plus 2 pi h times as large as the radius. Question 2. If the height of the cylinder is the same as the radius, what is the ratio of the surface area to the radius? Well, they're asking us for ratio again, but it says if the height is the same as the radius. So what does that mean? Well, up above we have r for radius and h for height. What they're saying is h is equal to r. So now let's go back to our original equation. The ratio is equal to surface area divided by radius. And we know that surface area is 2 pi r squared plus 2 pi r h. However, the new clue is that h is equal to r. So does this help us simplify? Well, what this means is wherever we see an h, we can replace it with an r. So in looking at my second term, I have 2 pi times r times r. Well, r times r is the same thing as r squared. So I now have 2 pi r squared plus 2 pi r squared. Hopefully you'll notice that these are like terms. They have the same variable and the same exponent. So I can combine them. I've got 2 of them in the first term and 2 of them in the second term, which means I have a total of 4 pi r squared. Now I can divide my radiuses. I've got 2 radiuses in the numerator and 1 radius in the denominator. So if I were to cancel those, that would leave me with 1 radius in the numerator. Or my answer is 4 pi r, or the surface area is 4 pi r times as large as the radius. And that would be my final answer.